To answer this question, I am privileged to have Dr. Russell Humphreys join us on the phone today. Dr. Humphreys received a Bachelor of Science degree in physics and a PhD in physics, specializing in cosmic rays and ultra-high energy nucleon-nucleon interactions. It's interesting that he committed his life to Christ and became a young Earth creationist during his years at school. Dr. Humphreys worked at Sandia National Laboratories in New Mexico from 1979 until 2001, when he retired to work full-time for the Institute for Creation Research as a professor of physics. He resigned from ICR in 2008 and now works as an independent researcher. Now, this has been a long time coming. I've had so many people specifically request if I could get you on the show. So it's great to have you on. Thanks for joining me, Dr. Humphreys, and welcome to the show.
It's a real privilege and a pleasure to be on your show. I get a huge kick out of it every time I watch it.
Well, thank you so much. So the first question that's on everyone's mind, a question I get asked so often, is that of distant starlight. Now, you, of course, are familiar with it. The question goes, we have stars that are 1 billion light years away, so it takes the light billions of years to get here. So how can light from a star even 1 billion light years away get here on Earth if the universe is only 6,000 years old? And I'm sure you would agree it's actually an excellent question. Now, having been a skeptic for so many years, I've gotten in the habit of looking past the question or problem and probing to some of the more unseen questions or assumptions behind it. And my first question is, are those stars really that far away? How do we know they are so far away?
Yeah, I get asked that question a lot. I always wonder what's behind the question. Are the creationists who ask that question, are they saying maybe the stars are no more than 6,000 light years away from us? All the stars that we can observe are that close to us, and then we would have no problem getting the starlight to us on Earth within 6,000 years. Is that kind of the what's behind that question, you think?
It's just a question partly for myself. It's more just out of curiosity. How do you know that the stars are so far away? And I know that some of the viewers would have that same question as well.
Okay. Well, I think a lot of people who are asking it want to say maybe the stars are only 6,000 light years away. And so if you take all the stars that the Hubble telescope can see, which is about 10 billion trillion, and stuff them into a sphere that has a radius of 6,000 light years, you get about 6 stars right in our own solar system. So I would think we would have noticed. So now, if they're further away than that, then the creationist, young Earth creationist, still has a problem. So the distance thing won't solve any problems. That's what I'm saying. But how we know, there's about a dozen different methods that astronomers use, and they overlap and they dovetail, and they agree with each other pretty well. And one of the most famous ones is Edwin Hubble back in the 1930 used Cepheid variables or Cepheid variables or Cepheid variables. I hope the astronomers will forgive me for mangling the pronunciation of that. Those are stars that we can observe in our own galaxy nearby. And we can measure the distances of those stars just by triangulating on them from as the Earth moves around in its orbit. So we know the distance of those stars, and they vary their light output from day to day or week to week, depending on how big the star is. And you can make a connection between how bright the star is and its period, whether it's days or a few weeks. So they serve as sort of a standard candle that Hubble used to look at the Andromeda galaxy, and he found some bright stars that varied from day to day and week to week. So he just, with his photographic plates, identified 3 or 4 of those Cepheid variables. Cepheid variables. Do you know how to pronounce that?
Yeah, I think it's Cepheid.
Cepheid. Okay. Anyhow, he knew how bright they were from nearby, so he could tell how bright they were in Andromeda Galaxy, and then just determine the intensity of the light from them that's reaching Earth, and use the 1 over distance squared law to determine how far away the galaxy was. And that was the first determination of how far away some of the nearby galaxies were. They didn't know whether they were outside of our own galaxy and just small clouds of gas, or they were really far away. So Cepheid variables is Cepheid variables, and another one is type 1A supernova, a particular type of supernova with a certain type of spectrum. And again, they know how bright they are when they go off in our own galaxy. And they can detect these up to 60 million light years away pretty easily now. And so they can again tell the brightness by knowing what type of supernova it is. They know its brightness, so it's putting out so many watts at its peak brightness of the explosion, and they can use the 1 over distance law again just to tell the distance. So those distances are really big out there, and that's not the solution to the creationist problem of how to get the distant starlight to us.
Excellent. Okay. So it is a legitimate question then. How do these light from distant stars get to us then? So do these distant stars not also pose problems even for those who believe the universe is billions of years old?
Well, they have a bit of a problem if they believe in the Big Bang Theory, because different parts of the universe appear to be at the same temperature, in particular the cosmic microwave background radiation, and it's hard within for one side of the universe to be at exactly the same temperature as the opposite side of the universe, if they're billions of light years away, which they are. And yet the speed of light is limited. So they have a bit of a problem with that.
Okay. Now, creationists have set out to answer this question of distant starlight in a number of ways. One of them is that perhaps God created not just the star, but also the light itself in transit. So in other words, God didn't just create the star, but also created, say, a whole string of light photons between the star and Earth. What do you think of that theory?
Well, first we need to know that there are events that we see out there in the cosmos. We see exploding stars and supernovas and other things that happen suddenly and drastically. And the light created in transit theory would require a false history of those events. Particular like an exploding star. We see an exploding star 100,000 light years away from us, and the light created in transit theory says that about 6,000 light years away from us, 6,000 years ago, God created the images of an exploding star, and those images then came in towards us and arrived recently. Now, the theory would say then that the actual star didn't explode either then or ever, so there would be no explosion. So we would be seeing a picture of an event that never happened, and so we would have a false history in the sky. And that deeply bothers me because it says in Psalm 19, the heavens declare the glory of God, and the firmament shows forth his handiwork. Now, if the heavens are declaring things that didn't happen, what does that say about God's glory? I think it's a bad thing to say, but I know some very fine creationists who aren't at all bothered by that. They say it's fine with them if God creates a false history. So it's a philosophical question, more or less, but a lot of creationists I knew back in the 80s, mid-80s, weren't very happy with that thing, so that set me on the trail of looking for a better answer. Now, Another problem with the theory is that it doesn't explain other things that we see, major features of the cosmos, such as the increase of redshift of light from distant galaxies as they get further and further away from us, or the cosmic microwave background radiation, why it's so uniform and what causes it. And then the third thing, there's no real scripture that says that particular thing happened. We don't know, as far as I know, no advocate of the light created in transit theory can say, now here's a scripture that says that's what God did. He can't do that. So there's just no scriptural basis for it either. So that's the problem with that theory. But I do want to emphasize that if a person is happy with that theory, they can just stop, not investigate my theory or any of the other creationist theories on cosmos, but just be happy. That's fine.
An excellent response. I like that. Now, what about the possibility that perhaps the speed of light has changed over time? In other words, the speed of light was many magnitudes faster in the past than it is now. Thus, the light actually got here really, really fast in the past, and now the speed of light has slowed down dramatically. And so a light year would have been far shorter in the past than now. How do you respond to that proposition?
Well, first I'd say probably by that, what you're getting at, a light year would have been far longer. It's a distance, and you're saying that a light year would be a great distance rather than...
oh, yes. Yes, I said that backwards. You're correct, yes.
So now, first, there's no data showing it. Barry Setterfield, who introduced that theory back in the mid-'80s, thought he had some several century-year-old data that pointed to a decrease in the speed of light still going on. But as the physical scientists in the creationist movement started looking at the data, it evaporated. When you actually analyze the data properly, there's no trend between 300 years ago and now. It's flat, no change. So no data. Now the second is something that might be a little hard to understand. The speed of light looks like it affects the rates of all physical processes, including gravity and including radioactivity and atomic clocks and watches and how fast you digest your meal and so on and so forth. So the speed of light affects the rates of all physical processes. If you speed up light's speed, then those physical processes will speed up with it in lockstep. As far as I can tell from all the physics data that I know, that's what would happen. So if you speed up light and you speed up, say, the rotation of the Earth around the Sun 1 year, you would have a shorter year and you would have faster light, but the product of how far light would go in 1 year would remain the same distance, same number of kilometers.
Right.
You with me on that?
If you drive faster, but at the same time your clock ticks faster, then your speed stays the same. I follow you there.
In other words, if the speed of light changes, everything changes, and as far as we can tell, we can't detect the change. Our clocks change right along with the speed of light, and we can't measure a change in it. So that was a serious problem. I raised it to Barry Setterfield, and he came back with a theory that said, well, maybe some clocks don't get changed and others do, but he never really managed to make that theory work. So there's this theoretical problem as well as the experimental problem.
Okay, very interesting. Now, speaking of interesting, you have built a fascinating model which would appear to answer the question of distant starlight. I know this is really complicated, but I know you're also really good at explaining complicated subjects, so let's give it a shot. What's the foundation of your model? If we could perhaps start there.
Well, if you remember back in Genesis chapter 1, God created an expanse in the middle of some waters. And the waters under that expanse later became the earth, and the expanse looks like it expanded billions of light years to be able to include all the stars and galaxies we now see. And then there were waters above that expanse. That biblical picture of things says then that the earth is, roughly near the center, at least on a cosmic scale of distances. The earth is roughly at the center of the universe. And that makes for some interesting situations regarding gravity and time. The bottom line of my theory is, in fact, I've got two theories, and both of them say this, that there would be a situation regarding gravity at the beginning of the world on the fourth day of creation, as measured with ordinary clocks here, an ordinary day. There would be a way that events way out in the universe could be going on very fast compared to our clocks here. And basically, this is something called gravitational time dilation. And it doesn't depend on the force of gravity or weight. It depends on the energy of gravity. It takes a certain amount of energy to lift an object from Earth all the way to the far reaches of the universe and out beyond the farthest star. And the Big Bang Theory doesn't suffer from, I shouldn't say, doesn't have this advantage. The Big Bang Theory says that there is no empty space way out there, and there is no center, that all places are pretty much the same, and there is no unique center. And so the Big Bang Theory does not have gravitational time dilation. But a Bible-based universe that does have a center has a center of gravity, and near the center of gravity at a certain time would be very much slower. Time would tick slower on Earth than it would way out in the distant universe. So this gives a way for light to get to us in a hurry as measured by our clocks. And our clocks are the ones that matter, because those are the ones that God set up in Genesis 1 to mark off time, days and years and signs and seasons, rotation of the earth, day and night, and so on. As measured by clocks on Earth, the universe would be very young, 6,000 years. But as measured by clocks way out there, you could get billions of years. And if you were way out there and you look back, could see what was happening on Earth on the fourth day of creation, it would look like things were dead stopped. No rotation, no orbiting. If you had been on Earth during that time and could have seen what was going on way out in the universe, it would look like a video in fast forward with things happening very fast. And if you could see it, the light zooming in towards us at faster than 186,000 miles per second, as measured by clocks right here on Earth. So it would be an ordinary day, as far as anyone could tell. You would eat 3 meals and feel like sleeping, but it would be a day in which an extraordinary thing would happen, and that is the light from distant galaxies would arrive on Earth.
Very interesting. So there's an unexpected variable there, which many people wouldn't grasp right away, which ironically I just touched on this subject in the Christmas special, actually, and that variable is time. We tend not to think of time as a variable. At least I tried to argue that time was a variable with my boss when I was late getting to work and delayed the train, but he didn't buy that argument. But time itself is a variable in all of this equation. So how does that play into all of your model then?
Well, it's the essence of my model. I'm saying that clocks don't tick at the same rate in different places at different times. That clocks do not tick at the same rate in different places in general. and that's an experimentally observed fact. People have this image in their head of clocks of time ticking at the same rate throughout the universe. In all the clocks are nicely synchronized, and everything ticks at the same rate. But the actual facts of physics don't allow that. We can measure differences in clock rates with differences in altitude with atomic clocks. And under some situations, when you're considering something the size of the universe, you can get drastic differences in clock rates. So it's a hard thing for people to get their heads around. But the hard thing is simply their preconception that time is something immutable, that it's beyond creation, that it's something almost sacred and ticks in unison throughout the universe. But the true fact is that time is a part of our created universe. It's just another part of God's creation. It started with the beginning. And so the time that we are enmeshed in, anyhow, let's say, there may be time outside of our created universe, probably is, but the time that we're enmeshed in is just another created servant of God, and he's able to have his servant behave just the way he wants to get things done. So I think he used time and relativity effects upon time as a way that we could see a really big universe in a very short time.
And that is really just a philosophical assumption for the Big Bang Theory, that there is no center, no edge, no empty space. Is that correct?
That's right.
And so basically, if there is a center and an edge, and if there is areas where there is more gravity, basically where there is more gravity in the universe, time slows down, is the essence of your model.
Yes. Two things to point out that people get tripped up over. One is that when we say an edge, what I'm meaning is simply a place where there are no more stars, where you reach the last star as you move up the last galaxy, and beyond that there's just some empty space of the same sort that we travel through. And that's what I mean by an edge to matter. The second thing is the word gravity to people usually means weight, gravitational force. So my theory gets distorted when it's reported to critics, and so they say, if it takes huge gravity to slow down clocks on Earth, then everything would weigh trillions of tons, and nobody would survive that. But it's not really gravitational force, not weight, but it's gravitational energy. And physicists have a name for the particular kind of energy. They call it potential energy. And that's the important thing in the time dilation equations, is this energy. Energy is not force. Energy is not weight. So there are no enormous elephants sitting upon Adam's chest as he views the time-dilated universe.
So now, another area which I've mentioned quite often on the show here is your theoretical work on planetary magnetic fields. You proposed a theory for the origin of the magnetic fields of planets, like Earth's. Everybody knows Earth has a magnetic field. That's how your compasses point north and south, or your iPhone nowadays. But you proposed a model for why Earth and other planets and even moons would have a magnetic field. Why don't you tell us about that?
Okay, it's based on the thing that set me off on this was I found that the Greek of 2 Peter 3:5 says something that isn't in some of our translations and is in other translations. But it says essentially in Greek, the earth was formed out of water and by means of water. And so I said, wow, that sounds like he made the earth all water and then transformed the water, obviously, to other stuff after that. And then going back to Genesis chapter 1 and looking at the second verse, darkness was on the face of the deep, and the Spirit of God was moving over the face of the waters. So it sounds like God made a lot of water first, and including making the earth of water down at the center of that body of large water called the deep. So if he made it of water, then those would be ordinary water molecules, I would think. And there's a way, it hit me, that God could make the right amount of magnetic field to explain the Earth's present magnetic field if, when he formed the water, if he made the water, created the water out of nothing, if he just created the hydrogen nuclei in each molecule. Those are little spinning balls of charge, little spinning protons, and because they spin, they have a magnetic field. And if he made all the spins of the many hydrogen nuclei and all those water molecules, if they all pointed in the same direction, you get a field that's roughly 10 times stronger than our present field. Then probably he converted the water to other stuff right away, and the spins went away. But once you've started a magnetic field tends to maintain itself. If there's anything even slightly electrically conducting around, the magnetic field will maintain itself by starting up an electric current in what will become the Earth's core. And so right now that current is about 6 billion amperes, and it circulates westward, and it's what maintains the Earth's magnetic field. And but it's a decaying magnetic field, and if you extrapolate that decay backwards 6,000 years, you get a field that's as strong as my lined up protons in the water would give you. And so I said, wow, that's really neat. Usually when physicists get crazy ideas like that, they're many orders of magnitude off, and so we fill our wastebaskets with crazy ideas that don't work. So I said, wow. So I published that in 1983 in the Creation Research Society Quarterly, a little article called The Creation of the Earth's Magnetic Field. And then that year I decided, well, it worked so well for the Earth, what about the other bodies in the solar system? The sun, the moon, the planets, and so forth. Some of those magnetic fields had been measured by that time for the sun, and by that time the moon's former magnetic field had been measured. It once had a strong magnetic field, according to the moon rocks the astronauts brought back. And some of the planets had been measured, but not all of them. So for the ones that have been measured, the theory fit very well. All you need to know is the mass of each planet, and that tells you how much water there might have been at the very beginning, and gives you the strength of the field. And then if you know something about the planet's conducting core, you can tell how fast electrical resistance will wear down the electrical current and make the field decay away. The bigger the core, the less fast it dies away. And there were estimates for these. So it fit very well for all the planets and bodies in the solar system that had been measured by spacecraft up to that time or by astronomical means. And but we didn't know the strength of the field for the planets Uranus and Neptune. And Voyager 2 was scheduled to go by that a few years after I published my article, Creation of Planetary Magnetic Fields, in the December 1984 Creation Research Society Quarterly. So I published a few predictions about what space probes would find in the future.
And predictions are the most powerful method of affirming or refuting a theory.
It's easy for a theorist after the fact, after a measurement's been made, to adjust knobs and bells and whistles on his theory so it fits a fact. It's harder to do that when you have a whole bunch of facts to fit, but nonetheless, if you go out on a limb and you say, well, here's what my theory says we should find, I can't adjust my prediction after it's been made and in print, and so it's a way of keeping the theorist honest. He just says this will either confirm my theory or break it.
Mm-hmm, mm-hmm. And I'm sure that must have been nerve-wracking to put your predictions in print back when the technology didn't even yet exist to verify some of your predictions. So have any of your predictions been proven or falsified yet?
Yeah, it really wasn't nerve-wracking. I have this loose attitude toward my theories. I admit the fact that I'm not God and I'm not writing scripture, and my theory might be wrong, and it will be no great disaster if my theory is wrong. Okay, so actually, I just said, here's a way you can. We'll both find out, you, the reader, and me, whether my theory sounds like it's right. And so I did. I went out and I made some predictions. Were you asking what the predictions were?
Yes. Have any of your predictions been proven or falsified yet?
Yes. All 5 predictions I made in that article, the important ones. There's a 6th one about Pluto that hasn't been checked yet, but not really a very dramatic prediction. It agrees with the evolutionary, because Pluto probably is made of ice and has no magnetic field left. It doesn't have a good enough conducting core. But the other 6 predictions I made have all come true, all been verified by spacecraft.
And yet those who believe in deep time and believe that our solar system is billions of years old are completely baffled by all of these points. In other words, did not these facts completely contradict all of their predictions?
Yeah, now I wouldn't say all of their predictions. I'll give you an example. The planet Uranus has no measurable heat flow according to infrared observations through telescopes. So they thought that the planet Uranus could not have what they call a magnetic dynamo generating any magnetic field. So they thought that when Voyager went by Uranus, it would detect very little field, if any. But my theory was saying, no, Uranus should have a pretty strong field, comparable to the strength of the Earth's field for that size planet. And so, the Voyager flew by Uranus, and my prediction was verified, and theirs wasn't. So then they updated their prediction for Neptune. They said, well, Neptune's a sister planet, sort of, to Uranus, and so it should have the same sort of magnetic field, so we're going to say that Neptune should also have a strong magnetic field, and then they moved it up to a range that pretty well was the same as my prediction already. So their predictions are sort of hand-waving. They can't get quantitative with their dynamo theories, even after nearly a century of developing them. So all they can do is sort of scale between planets, like we did here for Uranus and Neptune. But they had some pretty remarkable failures with the Mercury, with Mars, and they can't understand why the Moon had a strong magnetic field in the past and doesn't now. And so they've had some pretty strong failures, even with their hand-waving theory.
Right. Okay. Can I put you on the spot? Is there any predictions you could make based upon your starlight and time model? Predictions that could be tested?
Yes, although the theory needs to really be developed further to make some good predictions. And I have a list of things that, at the end of my book, some things that, if the theory is developed, it looks like certain things will happen. And one of those is evidence for the Earth and our galaxy being near a center. And there has turned up such evidence.
Oh, interesting.
Yes, that's the quantized redshifts, the fact that redshifts occur in bundles and bunches, and they're not smoothly distributed. Out. So those are proportional to distances, we think. And so it sort of suggests that the galaxies are arranged around our own galaxy in spherically concentric shells, statistically speaking. No real hard shells out there, just they tend to be at certain distances and not at others. That's evidence that we are near the center of that concentric arrangement, which is what one would expect if the Bible's account is correct of the Earth being near the center. So that's a very basic prediction. There's other evidence of that type. And then my second cosmology very nicely explains the deceleration of the Pioneer space probes as they got out far out beyond the edge of the solar system. They observed over a space of 10 years that the Pioneers were slowing down a little bit more than anything they could explain it with. But that data fits in nicely to my second cosmology, and I have an article in the Journal of Creation. That was volume 21, 2007. Creationist cosmologies solve the Pioneer anomaly.
Okay, well, thank you so much for your time. I know the viewers will really appreciate this, so I'll say a huge thank you for them and as well for myself. I really appreciate that you took time out to have this time with us.
Well, my pleasure to do so. Always a lot of fun.
You can learn more about Dr. Humphreys' Starlight in Time model either through his book or an excellent DVD production, which is a layman's explanation of the book, both available through the Creation Research Society. This interview was edited for television, but you can catch the entire interview on our YouTube channel. Just head on over to genesisweek.com, which takes you to our YouTube channel. Stick around. We'll be back in just a minute.